In this tutorial, we are going to study how characters, the basic characteristics of characters can be determined and also manipulated. So, first thing I'd like to do is let me start a program, and I'll say pound include iostream using namespace std, and let's go ahead and go into here, and I'm going to say int main and put in a system pause. First thing I'd like to do is, I mentioned earlier that sometimes we want to set the number of places that we see. So if I include iomanip, we can see the number of places within a number. So if I declare a variable as a double, and I'll set it equal to, I'll say x is equal to, and I'll just make up some crazy number, 1.2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, e to the power of, say, 308. And of course, this is pushing the limits of what a double can display. If I want to see the whole number, I want to see all these places that I put into it, I can use a command which is under iomanip, which is called set precision. So I'll say cout set precision, and then I just write the number of places I want to see. So if I want to see, say, 7 places, that's what you're going to get. Just simply use it before you output that variable. So I'll say cout set precision x and L. So if I go to rebuild this number, or this program, and I run my program, I seem to have an error. Let me find out what the issue is. Of course, I left out a semicolon here. Let's rebuild this, and we'll run it with the code that we have. And you can see now, if I count the places, I asked for 7 places. I see 1, 2, 3, 4, 5, 6, 7. Can you see it gives me exactly what I asked for? Now, all 15 places are recorded, so if you want to see everything, pump this up to about 15, and you should see the whole thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It gives you exactly what you ask for. So that's kind of a nice command to know about. The next thing I'd like to show you, these are all commands that you're going to see on your upcoming lab, is the toUpper command. So I'm going to declare a char. I'll say that I have a character which is the letter E, and I'll say it's just simply the letter E. The variable E is equal to the letter A. Now what I'd like to do is I'll say cout toUpper parentheses E. I'm able to use toUpper because I have iomanip up above. Iomanip is the command that I'm using here. So if I come down and I rebuild this and run it, I get the number 65. What you need to understand is 65 is the ASCII code value for an A. So in effect, what I'm getting here is a capital A, which makes a lot of sense. Unfortunately, we're not seeing the letter here, and this commonly happens in C++. If you actually want to see the letter, we now have a technique for forcing this to show the letter. What's the only thing I need to write in front? Char. This is going to force a character to appear. Now, some versions of C++, you may not even have to say char in front of this. It may give it to you. But what I tell you is you're a little more cross-compatible if you write in parentheses that you want to force the result to be a character. But the only place I'm going to tell you don't use typecasting is if you're trying to typecast something into something that it already is. Like if you have a double, don't try to typecast a double into a double. You may get an error on that. Certainly within Java that would happen. Okay, next thing I'd like to do here is I would like you to see what is the effect of to lower. So I'll go ahead and copy this line. I'll now take the character that I have at E and I'll set it equal to a uppercase A. And if I want to see what the lowercase version of an A is, I want to see a lowercase a. Obviously, instead of asking for to upper, I'm going to ask to lower. Again, to upper and to lower are both commands that come out of iomanip. So if I run this and look at it, there you go. There's the lowercase a. Again, I'm typecasting to make sure that I actually see the character. Now, there are a whole host of commands now that we can use in addition to manipulating the output to actually learning a little bit about the characters that we use. And if these are used wisely, there's just amazing things that you can do with this. The implications are great. One command that I can use that has to do with the character type, and to see that I need to include a new library that we've never seen before called C-type. And this is going to get me at some of the different character types. Now, character type is a standard header file with a .h extension. I don't think its equivalent is present among the standard library without the .h. And if I want to use one command from there, I could say something like cout is all num parentheses f, and I'm going to say indel, and I want to define what f is. And I'll define f as a char, and I'll set it equal to the letter z. At this particular point, I'm preparing you for your next lab after the Roman numerals lab, which deals with characters. So if I look at this, what I'm saying is f is equal to the letter z, and I'm outputting if z here is all num. Now just take a wild guess. What do you suppose all stands for? Alphabetical? What is num? A number? So it's really asking you, is this a letter or a number? That's really what it's asking. And if it is going to return something equivalent to true. Now you need to understand, true is anything but what value? 0. So when I output this, what you're going to see is something, anything, but not a 0. And I really can't tell you what I'm going to see. In this case, I'm going to see a 1. If I change this to a number, say I make this the number 5, I might get something different. I got a 4 here, but this is still true. This is true. It's telling me, yes, that's a number or a letter. Let's put in something which isn't a number or a letter. I'll put in a question mark. If I try to see what this is, there's only one thing it can send back to me. You know what I'll see? It's going to be a 0. So this is how you can get a little bit of information about the characters that you're using. And it sometimes might be handy to see if somebody inputted a number, inputted a character, because sometimes when we're asking people to give input when we give a prompt, we don't want them to provide the wrong kind of input. We want to make sure that they enter a number when they should give us a number, and then we want them to enter a character when we want to see a character. This can help us see if that goes on. Okay, so another one sometimes we deal with besides is all num is num. If I rebuild this, I guess I've got the wrong one. Let me say is punct. And obviously, question mark is punctuation, so it's really asking me, is this punctuation? I'm going to see something that isn't equal to 0 for a number. And I get the number 16. If you put in something else, maybe make it equal a period or a colon, you might see something else. So at any rate, there's a good number of these commands. If you refer to your notes, I have a pretty good list of these. We can see if a number is alphabetical or a number, if it's just alphabetical. If it's a number, the command is digit. We can also see if it is a control character. Examples of that would be like the shift key, the control key, so on. But those are still ASCII characters, as strange as those may seem. I can also see if it prints out to the screen by saying if it is graphable. I can see if it's lowercase by asking is lower. I can see if it's printable, if it's a punctuation character, if it's a space, if it's an uppercase letter. So I won't bore you with the details of making programs for all of those, but these are all possibilities that I could look for. You will have a lab in the future which deals with checking to see what kind of characters you have just inputted from the console to see if it's any of those things. At this point, this concludes the tutorial on character manipulations and determining character type.